I want to introduce Mr. Vintage Sailplane Guy to talk about vintage sailplanes, because if you're here, you probably know Neal, so I won't introduce him. But I just want to welcome you to the afternoon of the OSTIF Track Congress. If you're not a member of OSTIF, visit the booth downstairs, become a member. OSTIF is the International Organization for the Science and Technology of Soaring. We're responsible to report to EASA for sailplane regulations and so forth. So if you fly gliders, we affect what you do pretty dramatically. And if you want an input, join. Technical Soaring is published 4 times a year with technical articles. We have 3 panels. There's a technology panel, which is essentially sailplane design and aerodynamics and so forth, meteorology and training and safety. So I'm sure if you fly gliders, one of those involves you. So visit the booth, sign up, it's cheap, blah, blah, blah. And with no further, here.
Thank you. I know Mark from aerodynamics and our work that we've done for years. And I've been at Beach Aircraft and do consulting for a lot of different companies right now. So anyway, this one is talking about how we care for and keep vintage gliders in the air. Got an overview of the presentation. We've got a range of vintage and classic gliders, and then the VSA, the Vintage Sailplane Association, talking about its members, its archive, the things that are available through the VSA for maintaining aircraft. Workshop Practice is a book. It's a translation of Werkstattpraxis für den Bau von Gleit- und Segelflugzeugen. It was written by Hans Jakob originally back in the mid-1930s, and the last edition was in 1955. And Simon over here and I were the co-editors that finally got it across the line and got it in the translation in print. So it's an English language translation, which is available down in the VSA booth downstairs. And then it talks some about some other references. Know the wood. It's important with these old wooden gliders to know what you're dealing with to make proper repairs and maintain airworthiness, and talk about some glider restoration, and at the end, possible recreations. You've got the vintage, you've got iconic gliders from the 1930s. These are both U.S. gliders, okay? The Bolas Senior Albatross there and the Zenonia. The Zenonia is on display at the NSM now, and the Bolas that's in Air and Space Museum, isn't it? So, and there's also one on display at the NSM. And you notice the one on the left has a strutted wing, okay? But even in the 1930s, there was a transition over to cantilever wings, okay? You look at utility gliders from the 1930s and 40s. A Grunau baby in the upper left, built in the thousands, over in Germany, designed about 1936. The Schweitzer 119, the Briegleb on the west coast, the Briegleb BG6 there, and then a Midwest utility built in Chicago. So you had Germany, New York State, California, and Chicago represented all here. And these utility gliders provided stepping stones to the higher performance gliders. Then you have iconic European gliders from the 1930s, the Minimo on the left, Hans Jakob's Olympia Misa on the upper right, and then below it, the Orlik from Poland. So the Misa was designed for the 1940 Olympics and was accepted, and that became called the Olympia. And then the Minimo and Orlik were used in competitions even after World War II. You have other wood 15-meter class gliders, standard class gliders, developed in the 1950s. Starting on the upper left, you got an L-Spats there. This is an L-Spats 55 version. The Schleicher K8, the Schempp-Hirth Standard Austria below, and the red KA6 CR model here. These reached L over Ds of about 32 to 1, maybe slightly higher. And you still got a good number of these that are maintained airworthy. Wood two-seat gliders for training or fun. The Schleicher K4 in the upper left. On the right, there's a K2B, which has an all-wood fuselage. You replace the wood fuselage with a steel tubing one, and you have the K7 right in the middle. And then the Bergfalke 4 is then a compatriot of the ASK 13 in the lower right. So the Schleicher gliders went from Kaiser designed this one, used these wings and tail surfaces on this steel tube fuselage with a shoulder mounted wing, and then went to the lower wing position here, but still using the same wings and tail surfaces off these in essence. But it allowed you to have a single piece canopy over both occupants. And all of these gliders, is still a fair number of these out there available, so you can do inexpensive flying and with people, with another person. The transition to fiberglass composite construction, the Phoenix FS-24, here's the prototype. It's out of a magazine in 1958, but it actually made its first flight, I believe, in November of 57 at the Hanweide. And then the Phoenix FS-24T on approach and landing, it has large split flaps. And then you can see the split flaps out there. And I believe that's Jim flying it there, landing at Wichita Glider Port. They only made 8 of these. The L over D approach is 40. They had orders for more, but the factory that was giving them space and stuff said, you need to make this more friendly for manufacture. And so it changed from the Phoenix to become the Phoebus. And they made a lot of Phoebus gliders. You get to first generation fiberglass when you really went into more than that type 8 production and such. And you have the 301 Labella and its cousin, the 201. And then you have the Schempp-Hirth Cirrus here. And these still are about approaching 40 to 1, but they're designed for higher speed around the course. The Phoenix had a very large wing area. It was a very good floater. It would stay up very nice. But these ones had much smaller wing areas and better for cross country. Early motor gliders. You go back and the motor spats in the upper left, the ASK-14, those 2 gliders used a 4-cylinder, 2-cycle, 4-carburetor geared 26 horsepower Hirth engine. And then in the lower left, a VW engine derivative used in the SF-25. And then similarly in the RF-5 2-place on the right. But these are all wood wing gliders with 3 of them steel tube. The 14 has a molded wood fuselage. The Vintage Sailplane Association has members throughout North America, and these members can provide experience and mentoring abilities to maintain, repair, and restore these gliders. We have 8 to 10 meets a year scheduled from the East Coast to the West Coast. We have an excellent quarterly magazine with news on membership events, details on members' projects, and information for maintenance and restoration. Our editor is over there in the green uh, uh, pullover. So, and it's it's an excellent magazine. And technical articles that appeared in this magazine are like things. I've written articles on various glues that were used for the building of gliders, and so 3 different ones that are shown here. And some of these articles were two part, but casein gliders glues that were used before World War II, the European glues used after World War II into the 50s, and then talking about using epoxy for wood glider repair. The VSA also has a drawing archive, which is fairly extensive, and I've obtained vintage drawings from many sources, and then I have them digitally scanned. Condition varies pretty widely, and so a number of them need attention. The goal is to make these drawings usable so that people can maintain their gliders in airworthy condition. I use Photoshop to clean up the drawings, and I have some examples here on this. This is a...
I just want to say for anybody that doesn't know yet, Neal has done incredible amounts of work. What he's done in these drawings has probably made the VSA archive the best one in the world at this point. And these drawings, from the ones he just started to the ones he's totally cleaned up, it's a monumental job and monumental work. And Neal needs a lot of applause.
This is a drawing that was in reasonable condition, but there's tears through it here, coming down and across over here, and just a variety of mild background noise and stuff. And so I removed the tape repairs, some of the other stuff, and completely bring it out to what it would look like when it was original. So this is drawing like from about 1943. It was a wartime drawing from Germany, Schneider. You get to some of these extreme cases, and unfortunately, I needed to get this drawing cleaned up because I've got a glider that needs the repair on these fuselage bulkheads. And so it was an original, the ammonia process, diazo process that they used to duplicate, and it was how many duplications down the line, I don't know. And then all the moisture and everything. And so that's what's in that drawing. Okay. So, and here, and sometimes I get drawings in pieces. Somebody's done on pieces on a copier, and then you have to put the parts together. And so you get the parts kind of in alignment, and then you finish up the cleaning to get to where you need to be. This is a partial list of what we have out there in the thing, but we've got gliders. The Breegleb gliders are from Gus Breegleb out in California, and the Cherokee 2. We have those. They're limited distribution. We can make them available to people that have an existing Cherokee project, but we honor the request of the designer not to send them out for new construction. The Crown City Glider Cub out in LA did the Screaming Wiener, Rigid Midget, and Little Doggy, and we have some of those drawings now all scanned. The Denver Utility, I borrowed, it's like the Holster Teufel primary glider with a canoe around where you sit. And I borrowed them from the National Soaring Museum and scanned them, and then got them, and it has a complete manual, like 180 some pages on how to go about building them. The fall valve, all these other ones there. I've got a good number of Schleicher drawings. And so if somebody needs something in this country, I can typically provide it for them. But Schleicher is very good still about providing glider support to these old aircraft. The workshop practice, the book, Werkstattpraxis, the first edition in 32, the seventh in 55. And it is really considered to be the authority for fabrication of wooden aircraft, okay, wooden gliders. We started the translation in 2016, and well, actually we started it, I've lost count how many years ago. We got to the first translation in 2016. It was to first printing, and the second printing with slight revision in 2020. The Hans Jakob, as a designer, he was the head of the DFS, the German Ministry for Sailplanes, in the 30s. And so he was a prolific designer back then, and really shaped how gliders were built and how clubs were set up over there with this book. And so there's the VSA book has books from the second printing, the green one there down in the at the booth. Wood was the prevalent building material up until about sailplanes up to 1960. The Phoenix was in late 1957, and it started the movement into fiberglass. So power aircraft had shifted from wood to metal immediately after World War II. But research in wood and wood adhesives really peaked in the 1930s, and during World War II. But when you got to the 50s, everything had shifted on to fiber reinforced composites. So while there are no commercially available aircraft using wood at this time, well, very few, I can think of a couple, but it's still widely used for home builds. Actually, Scheibe Sailplanes in Heubach, Germany, still builds the SF, a Super Falca, a motor glider, which has wood wings off the old designs. There's interesting articles and such talking about wartime use of wood for non-combat aircraft. I worked at Beech for about 28 years, and the Beech during World War II built wooden aircraft, training aircraft like that. And then in 2014, there was a neat book that came out that detailed how the forest industry in Wisconsin was harvested to get the wood for World War II aircraft. And ANC 18, this June 51 issue, is Design of Wood Aircraft Structures. And it's basically about the last thing that really talks about government publication to talk about wood in aircraft. But there is the Wood Handbook book from the Forest Products Lab, and it is maintained because with building industry, everything, furniture, it keeps up current, it adds new adhesives, it does all sorts of things, and it's an excellent resource, and the latest edition is available online. Wood types. Spruce is used commonly in the US, and so when the government here looked at things like in that previous publication or in the guidance that you get. Um, oh, what's I'm drawing a blank, Adam. The basic workman's handbook from the FAA. For yeah, it has some wood things in it, but it is almost exclusively based on spruce. Okay, because that's what was used here. No, in Germany, the gliders were typically built using Pfeiffer, which is a German word for Northern European pine. It's similar in strength to Douglas fir or Southern yellow pine here in the States, but that means it's 15% stronger than spruce. So if you would simply replace something on a German glider with spruce, you have to know where you're doing and how much the loading is, whether that would work or not, okay? Another wood that is used in some of the German gliders is TBU 7. I don't know what T exactly, but BU is Birk. It's the beech. It's unidirectional laminated beech veneer. It's engineered lumber. And so it's even stronger than Pfeiffer, and it has no internal flaws because you're working with veneer. So it has, and the 7 here means that it has 7 layers per centimeter. So each one of these layers is 1.2 millimeters thick, okay? And the big thing to do is you need to identify the wood and realize that these woods are not interchangeable. And so you have to have some engineering help to understand as you make your repairs. And showing here on the left is a drawing for a K2 spar, and on the right's a K2B spar. And they're the same basic wing, okay? But the K2 had TBU 7, and it's much smaller in cross section on the spar caps than the K2B. And wood scarfs and structural members. Scarfs are where you bevel the two pieces you're putting together and you get an overlap. So you've got a long overlap here on the bottom, you got a shorter overlap on the top. And so the ratio of the length of this to the thickness gives you what you're wanting to do is do that scarf joint so that the shear stress in the glue joint is always stronger than the wood you're gluing together. And so that means that as you get to a stronger wood, you have to make it shallower and shallower, okay? So for spruce, you can use a 15:1, as in AC 4313, the FAA publication. But if you're doing Pfeiffer, you need to use 20:1. And if you're using TBU 7, you need to use 30:1. So you have to understand these things when you're looking at some of these older aircraft. You can see here, this is a K6 glider that had old cotton on it. And you can see I've got a half moon gusset here and a half moon gusset here. These are what they are in place. So these fell off when the fabric got taken off. And so that means that all these joints, you have to go through and double check everything. And so these ones now are having the gussets scraped, cleaned up, and put back on using clothespins to hold them in place. The problem is that the Carete glue, it's a resin glue, depending on how everything was made, the mixing, the age of the glue, everything else, some gliders have no problem with the joints and others do have some problems. So, and the majority of them appear to be trailing edge ribs in wings. And that, according to second, third hand type conversations I've had. When they were building these aircraft at high rate back in the 1950s, early 60s, they farmed out some of these rib assemblies to be built by people in the local village, and their quality control was probably less stringent than within the factory. I've never found a failure in the leading edge, because I think those had to be controlled by the factory to get all their, but they could get these other ones done. So regardless, you have to go and inspect carefully everywhere and do repair as needed. Having a ring like this, my son knew a fella in town whose family had a architectural metals company, and so we made up 4 rings, one back here, one here, and then overlapped the tube. They had a big slip roll. We overlapped, cut the tubes. My son welded them together. I built the tabs and he welded them on. And then so having a steel tube rotisserie like this allows me to work totally by myself in the shop. Don't have to have somebody else to help turn things over. And then the poor man's ring here, I went ahead and just designed up a rotisserie that I used on a K2B 2-place glider so that I could do the fuselage work. And this is made from one 4x4 sheet of 3/4 inch plywood by laying out the segments there. So you've got 3 red segments, 3 blue segments. The red form one layer and the blue form the other layer, offset 60 degrees, so that you're all staggered there, and that's got plenty of strength to hold these together. And workshop practice describes doing these manufacture and repairs. Here it's like a leading edge of a K2 wing that I did not like the plywood on the outer panel. It was probably structurally safe, but it was very wrinkled and older, and I wanted to be able to check inside anyway. And so removed the plywood off the leading edge. You can see one light segment right here, and here I'm gluing on wood strips to make those ribs wider, so I have a bigger place on which your sheets are only so wide, and that's where I'll match up, go from one sheet to the next. And then you've got a plywood piece here in the middle that I preform around a plastic tube with clamps and boards on either side. I moisten it and get it soaked and let it dry, and then I have it preformed so it'll go around the tight leading edge. And then here shows it being glued in place and clamped at the ends with matching wood pieces with felt to provide uniform pressure on it, and then band clamps here in the middle and back at the spar having other strips of wood in there. So it becomes a clamping exercise. It just takes a little bit of effort, but it's fairly straightforward. And again, workshop practice tells you how to go about this properly and make it work. I'll also notice the Germans like the grain on a 45-degree angle here. It allows you to get the strongest resistance to shear, to torsion in the wing with the minimum thickness of plywood. But it means bending those sheets is a real pain in the caboose, because it doesn't want to bend on the bias, okay? So Now the British gliders said, screw it, we'll make it 1 gauge thicker in plywood, and we'll do everything on the lawn. We'll put the outside layers parallel to the span of the wing, which makes it a whole lot easier. And so here this shows the next step after I've got the 2 pieces I put on there and then getting the tip all ready. And this is what it looks like when you get it all completed there. And you notice too that I have a stand down at this end and I have a stand here, so I can again move these around the shop and do this very nicely and easily. And this glider will show up later. And one of the things you have to do with most of these gliders is put fabric on. And the lower surface of the ribs on most of the gliders are under cambered. So you need to rib stitch the lower surface. And by having one of those rotary stands that I showed there where I could move it around and put it at the angle I want, I could put it at 45 degrees angle. I could stand up, push the needle through one side, sit down on a stool and do the knot on the inside, push it back through and stand up. So I didn't have to have somebody else in the hangar to do it. So I could do it by myself. And on the left, this is, you end up with the fabric on the bottom. It's all rib stitched. I then bring the fabric around the trailing edge into the open bay on the top. And I could cut it off right at the edge of the wood. Often I just cut it at the ribs and let it drape down and in. And then I put the fabric on the upper surface. It'll overlap 50 millimeters, 2 inches onto the plywood, and then it will go to the trailing edge, and I'll take it around 1 inch or so beyond that and do a nice pinked edge so that you have a clean looking installation on it. And Stewart system was used for this. It's a waterborne system. And so there's a picture of my lovely girlfriend in the hangar. We've been married 49 years. So anyway, she would not show up in the hangar if I was using the older style fabric covering system. And so the one that was in the wooden ring earlier, that's the fuselage for it. And I did it about 12 years ago. And so Vincenzo, our friend from Italy, who comes over for some of the vintage meets, took this photograph in 2012 at Elmira at the IVSM meet there. The wing where you saw it all opened on the end and the plywood replacement, this is that glider. I completed it about 1.5 years ago, and it was at the IVSM this past summer in July. And Alex Gilles from Germany did the was in the chase, was in the one of the tow planes, and they used it to do chase for photographs. There are many of these gliders available, especially like K6s, K8s, that sort of thing. This is the first glider that I purchased, and I restored it back in the mid-90s, 1958 Schleicher K6BR, and that's at my local field. There's also the opportunity to do a recreation with the drawing archive and with various resources we have now. There's some things you could do it. You could do it totally old school, or you could use more modern techniques and such. Many of these classic older designs are really nice to fly. Some are very simple to build. Others have the real iconic look that you're trying to get, or important historical design features and such. So if you really want to be in the cockpit of one of these, and you have some home building skills, You can look for existing plans and builder instructions, and VSA or the ESA, the Experimental Sailplane Association, can help you out with that sort of thing. Hooder 17, I have multiple sets of drawings for this glider. It's a very simple glider with a 10-meter wingspan, open cockpit. This glider used to reside in eastern Pennsylvania for many years after coming over from England, and now is out at Tehachapi in California with a new steward out there. The Grunau Baby 2B was built in large numbers for training German pilots during World War II or the Hitler Youth. And I was able to work with the type design holder in Germany and people in Australia and California and England, and we put together the most complete set of drawings for this glider. A 1936 Rune Buzzard. It started out as a restoration project and ended up being a recreation. They jacked up the data plate and maybe saved a few fittings, but it was built with spruce instead of Pfeiffer, so all of the spar fittings and the spar caps had to be upsized, and then it had to, so all the fittings had to be adjusted accordingly. So it started out that way. This is at the SSA convention in Albuquerque a long time ago. And then it was finished off, and I was fortunate to get to fly it in Illinois one time. Delightful glider to fly. Wartime TG-4A, an LK-10. Dean Gradwell up in Oregon has been doing the restoration work on this. There were some of the tail surfaces that were beyond restoration, and he just built new tail surfaces then. And the LK-10 owners that have been really good about scrounging things, and one of them came up with a very nice set of drawings. And so the VSA now has a pretty good accumulation of drawings for this glider. It was, and like according to Colin and Brody in their presentation earlier today, it's a much better gliding sailplane than they really needed for training for the mission. And then if you use the old school construction methods, you have traditional stick-built ribs. And so you start counting the number of sticks that you have, verticals and diagonals, through a rib here for a K6. And then you realize you have long gussets along here, curved ones, and you have these half moon gussets all along here on the other side. And so you start counting the number of pieces and parts. Well, Gus Briegleb out in California did not want to do that with his home-built glider. So his ribs have part 27A, part 27B, part 27C. And those are plywood, 1/4-inch plywood, and they're just simply bandsaw cut and then sanded to match the profile. They may be a little bit heavier, but they're a whole lot more likely that somebody, if you're doing a home built, will get the job done. Okay? And so, but if I want to take that one step further, If you have the plans digital, you can use a CNC router to do a tapered wing, whatever you want, okay? And you have no tooling to set up for each rib. You have all these other, you just simply have them done. And you can probably even have them label each rib with a number on them, okay? Likewise, if you look at fuselage frames, the one on the left is the main frame that picks up the wing fitting on a Kirby gull. And it has laminated outer um, ribs going out, these caps coming up here. It has all these other pieces. It has laminations up in here. You've got to, and you have to have a board out, a board that you can put everything on, and nails or blocks to hold everything in place while it glues. Whereas Gus Preglove on the right, that's, you just cut that out of a plywood sheet. So there's some options out there. You can find an intact glider and you pamper it and enjoy it and fly it and have whatever you want, okay? You can find a glider that's got some condition issues and refurbish it, okay? We have the information that we can provide to help people do that. Or you can choose an iconic glider type and make it a modern reality, put it together your own way. So you got a Hooder 28, I'm sorry, and a Minimoa. And we have drawing sets for both of those. But most of all, have fun. And so this is from back in 2009 at the Wichita regional meet. And so we went from 1948 at the back end up to a duster here on this end that was what, 70s or 80s?